Hello, and I'm back, and now we want to first talk about what is the purpose of a telescope. Now, you might be thinking that the purpose of a telescope is to magnify. Well, that's certainly true if you're talking about telescopes on Earth. So, if you are using a telescope to look at an object on Earth, like a mountain, or if you're looking at a bird or something, you generally want to magnify that image. But it doesn't really help us if we're magnifying the image of a star. Because if a star normally looks like that, then when we magnify it, it's going to look like that, which really doesn't help us any. So you don't really consider the magnification power of a astronomical telescope. Okay, however, what we are interested in is that a telescope collect as much light as possible because stars are very faint. And so the more light coming from that star we can collect, the better the image of that star is going to be. And then we also want to take that light and then bring it to a focus where we're going to put a detector. So in this picture here, you can see that light is coming in from this direction, and it's going down the barrel, and then it's bouncing off the back of that telescope. So this is going to be called a reflecting telescope. And then the light then goes back this way, and it bounces off a secondary mirror. And the purpose of that is just to change the direction of the light so that it's now going this way, and then it goes into some kind of a detector. And later we're going to find out that an example of a detector would be a photometer that measures the brightness of light, and then also a diffraction grating, which is going to take the light and spread it out into the colors of it. So that's the purpose of a modern astronomical telescope. Okay, now let's talk about two different ways of bending light. So we want to talk about reflection and then refraction. So reflection is going to be whenever a wave or even a particle bounces off of something. So for example, let's say that this is the floor, and then you've got a person over here, and they've got a basketball, and they're trying to pass it to somebody over here. Well, this is a little experiment that you could try. What you want to do is take the basketball and aim for right in the middle. So if you're 6 feet apart, then 3 feet, aim the basketball there, and if the basketball isn't spinning, it will bounce and it will be reflected to the other person. Okay? So you might want to try that at home. But that's an example of reflection when it comes to a particle. But this person could also have a flashlight, and they could shine light on the floor, and then that light, if this was a mirror, would be reflected into this other person, so that it works for both light and for particles. So reflection is going to be the bending of a wave or a particle when it bounces off of something. Now this is a flat mirror, but we could also have a curved mirror, and there are two kinds of curved mirrors. So that you can have what's called a concave mirror, because if the light's coming from this direction, this mirror is making a cave. And you can see from the picture that light that's coming in up here will be reflected that way, and then light that's coming in this way is going to be reflected that way. And so where all of this light is coming to a point, that's going to be called the focus F of that particular mirror. And this is going to be very important because this is the kind of mirror that's going to be in the back of reflecting telescopes, is going to be this concave mirror thing. So notice it focuses the light, and so a example of this might be a solar hot dog cooker, where you've got sunlight coming in and then it's being reflected to this point, and then that's where you put your food if you want to cook it. Another kind of mirror, though, is going to be called the convex mirror, and it's going to look like this. So light's going to come in, but this time light's going to come in and it's going to ricochet off like this. So it's going to diverge the light. This one converges the light. This one's diverging the light. So another name for a concave mirror is a converging mirror. And then this one down here, the convex mirror, another name for it is a diverging mirror because it diverges the light. It does have a focus. So if you could take these lines and extend them behind the mirror, now you can't really reach behind a mirror, okay? But if you could imagine that those lines could go behind the mirror, it would come to this point right here, which would be the focus. So even one of these kinds of mirrors has a focus. Now, where do you find these kinds of mirrors? At a hospital or a supermarket where you need to be able to see around corners, or you need to be able to see if people are stealing stuff. And so it gives you a wide field of view. But the bad thing about it is it makes everything look smaller in the mirror, which is the reason why on your side mirrors of your car, what does it say? Objects in the mirror are closer than they appear. Okay, because when you look out your mirrors, the good news is you get a wide field of view of the cars that are on the sides of you. But the bad news is that it makes everything look smaller in order to be able to fit it onto that mirror. Okay, now you can also have things that are refracted. So refraction is going to be the bending of a wave when it's going through a material. So in that picture there, you have, let's say that you have light that is going in this direction and it's in air, so A for air, and then it's going to go into glass. Now this would be the direction that it would go if there was no piece of glass. And I just realized that you can't see that, so hold on. I'm on a roll. Hold on. Okay, let's try this again. So let's put my piece of glass over here. There we go. And here, this is the direction of the light. And then this is the direction that it would go in if there was no piece of glass. But because of the piece of glass, it's going to be deflected. So this line right here is perpendicular to the piece of glass. And then you can see that the light is going to go in this direction. Now there is a formula for all of this. So we're not going to get into it. But if you take a physics class, you would learn how to actually predict which way is the light going to bend mathematically. We're not going to do that. But it can be done. So all I want you to see is that when light goes into a piece of glass or water, it's going to bend. And we're going to call that refraction. And in the same way that we've got two different kinds of mirrors, we can have two different kinds of lenses. So the lens that is kind of like the converging mirror is the converging lens. And so it is going to be shaped like this. And then the one that goes with this, which is the diverging mirror, would be a diverging lens. And it is going to be shaped like this. And astronomers use all sorts of different kinds of lenses and mirrors in their telescopes in order to change the direction that the light is going in. Okay, we're going to take a break, and when we come back, we're going to talk about elements of a telescope.